Dear friends, the next operation is deleting a node at the end of a given linked list. Meaning, so we have a linked list. Let's say this is a linked list given which we know p equal to create. So we created 3 nodes. I want to delete the last node. Go to the end of the list. So I need to traverse, reach this node, delete this node so that I can remove this particular node. Now we need to remove this node, delete it. We know it's like cutting a tree. If I'm cutting a branch, I cannot be sitting on the branch cutting. I need to be sitting before, else I lose track of the rest of the tree. So we are going to do an operation in order to do this. Of course, we have to traverse. We need to move and come to the last node so that I can be deleted. But it is good that if I know my previous node, so that when I cutting this branch, I can stand here and cut this node, but I should also keep track of my previous node, because this point should become null, because I'm going to lose the last nodes of this, which means I should know the node to be deleted. I should also know my previous node. So let's see how this can be taken care of. So let's go to the explanation here. So let's look at this diagram. Of course, don't mind the arrows and the lines. We will see as we move ahead. Alright, now if I need to traverse, as I know, I need to keep my pointer at the beginning, not to lose track of the start of the list. So I'm going to keep my P, which is my original, always here. So P will remain here. But now in my style of operation, how we are going to do is, I'm going to move a pointer so that I reach on the node that I need to delete. I need to cut this branch away, but I should know my previous node. So I'm going to keep 2 pointers for this. Now initially both the pointers are kept on P, so we have Q and R both pointing at the beginning. So we have this line Q equal to R equal to P. That means 2 are going to point at the beginning of the linked list. Then I'm going to traverse using my Q, P remaining always there, so that I have the beginning. I'm going to use my Q to traverse till I reach on my last node. So we have a statement while Q next not equal to null. So Q is here, next is not null, that means there is a node, next is not null, so it will go to this node, next again not null, so second time it will go here, third time when it come here, while Q of next it is null, so the loop stops here. Now look at R. R actually runs behind or traverses behind in the loop. So what happens, R is first on Q. So when Q next, Q is here, then Q is first here, then when Q moves here, R is still here, and Q moves to third, R is on the previous, because R equal to Q is behind or before Q traverses, Q moves to the next. So when I have reached, Q has reached here and stops, the loop stops. Q is on this particular node, Q is here, Q is on this, while R is here. So using this, now I can delete this node, and I can also, I have hold of my previous node. So now let us see what happens in the remaining statements. So I have reached this node and have kept track of this. Now I'm going to free Q. Free Q means I'm going to just delete this node. This node will be completely freed. Free Q. So this is my last node. Having freed this, now this should not point to a node. So I'm going to do an operation R next equal to null, because this is going to be null now. This is my R. So R next is going to null. R next going to null, which means now this will point to nowhere. So here R next equal to null, and what you will get here is now R will become on this node. That is my last node. That's my R. and of course then return P because my pointer is at the beginning of the list P, which will be returned, and I have my original list which can be printed using a statement called print P. So once you look at this diagram, now I think it's clear. So I have deleted this node and I have also kept this as null. Thank you.